3.4 Examples on Speedup. In this part, I like to give you 2 examples to explain how to use the Speedup formula. All right, so let's start with the first question. Example number 12, based on our current sequence. We want to improve the performance of a task with some new technology. Assume that the speedup of the enhanced part is S. Okay, yeah, all right. Then after the enhancement, the execution time used in the enhanced part is 2/5 of the total execution time. And the overall speedup is 1.5. How much is the local speedup? How much is the local speedup? So look at this question. So I hope you read this question several times, 2 or 3 times at least. Try to understand all the details in this one. Most part pretty normal, but there is one key part I want to point it out. After enhancement. After enhancement. Remember, we have a line. We draw a line before enhancement, after enhancement. Okay? So that is important. Yeah. Now, I want to ask you, what is this fraction? What is the meaning of this fraction? 2/5. 2/5 used in the enhanced part. 2/5. What's that? Is it FEN? Yeah, the first question. Difficult, not that. It is very easy to get confused. The first question, that is easy to get confused. This one, is it FEN? If you look at it, the answer is no. It is not. So this 2/5 is not FEN. No. Why? The answer is simple. When we use FEN, what time is this fraction used? Before enhancement. Right? Yeah. This 2/5 after enhancement. Right? So that's why I draw this after enhancement. They are different. Yeah. Very easy to get confused. Yeah. In our textbook, it also emphasizes this point. Yeah. So this is the biggest thing that people could get confused. Yeah. All right, so if you pay attention to this one, then it will, much better for you to solve this problem correctly. So let's look at that, how to solve this problem. All right. First, let's draw some diagram to solve. For a question like this, we always draw a diagram like this. So FEN, 1 minus FEN, you will always draw a diagram like this. I hope when you solve questions of this type, you also draw a diagram on your scratch paper in this way. Otherwise, if you just try to use your imagination, not easy. Yeah. Many times you can get it wrong. Yeah. All right. Now, T old before after. Okay, yeah. So we use this timeline, to help us understand, how do we put those numbers? So FEN we put before line, before part. Okay, before enhancement part. 2/5 we put after enhancement part. Okay, yeah. Then, okay, all right. So this arrow now, so this is before. Now the arrow going down after. After, the enhanced part will become FEN over S. FEN over S. Yeah, because the enhanced part, the execution time will be reduced. Reduced by how much? Divided by local speed up, S. So we call it local speed up, divided by local speed up S, because S, we know, greater than 1. So you divide it by S, so the number will be smaller. So you reduced that part. Yeah. All right, so now these two, now we set up equation. Okay, now we set up equation using this 2/5, using this 2/5. All right. So the time used for the enhanced part, this much. Okay, yeah. FEN over S, although we can multiply T new, because both sides, although, sometimes people may feel we should multiply T new, both sides, right? So you can understand a little better. Yeah, so then we do cancellation, right? Yeah. So the time, actually, you multiply T new, so yeah, that is 2/5 of the total. Yeah, the total part. Oh, sorry. Oh, sorry, T old, right? Yeah, because, T new, we do not know T new, right? Sorry, T old, yeah. Because the T old we carry from above. We carry from above, okay? Also T old, yeah, not T new. So we carried from above, okay? All right. So then we can do cancellation. Yeah. 2/5 of the total execution time. So this is T new. So this is T new. Okay? Yeah. After cancellation, we get one equation. In this equation, we have two unknowns. FEN unknown, S unknown. Two unknowns. But we only have one equation. How can we solve it? We cannot. Two unknowns with one equation, we cannot solve it, to get a solution. So we need another equation. Remember, we have the overall speed up 1.5. That can help us set up our second equation. Okay? So we get a second equation. All right, so let's continue so we already have the first equation, but now we need a second equation using this 1.5. The formula. This time we use the global speed up formula. This one, 1.5 equals 1 over FEN over S plus 1 minus FEN. That's the standard formula we derived last time. So now, two equations with two unknowns, then we can solve it. We can solve it. But this time, I hope you have the sufficient algebra skills to solve this problem. Now, in this class, we will have many questions like this. Now, after you set up correct equations, you need to solve it correctly. Okay, yeah. So here, yeah, hope you can do it. Yeah. All right, so let me work it out, going through all the important steps, yeah, and hope you can follow. First, from this equation, we can find the denominator value, right? Yeah. Denominator equals 1 over 1.5, 2/3. Yeah. So you treat this whole thing as one quantity. Yeah. So you find its value. And you can see this one the same as that parenthesis. That big parenthesis, its value is known, right? Okay, yeah. So you need to have sharp eyes to see this. Then you can solve it faster. Yeah. All right. Then you can calculate that number. Yeah, because you can do substitution. Replace that big parenthesis by 2/3. So you get a number 4/15. That is Fen over S. Fen over S equals 4/15. Okay, Fen over S equals 4/15. So you can find Fen equals 2/3 minus 4/15. You replace it by that 4/15. Okay, so that easy. Then you find Fen equals 3/5. Okay, 3/5. Yeah. Then find S. So now S equals 3/5 over 4/15. You simplify it, 9/4, 2.25. 2.425. Yeah. All right. So that's the final answer. Yeah, because we need to find the local speed up, S. So finally, we find this number. That is the final answer. Yeah. So think about this whole procedure. The key part, yeah. First thing you need to pay attention after enhancement. Because usually many students, based on the common psychology, when they have a formula, they tend to plug in some numbers that should be there. For example, when they see a fraction, they automatically connect it to Fen, but actually, it's not correct. Incorrect. Do not connect it to Fen. So that's the first thing. Second thing, draw a diagram to help you set up equations. When you draw a diagram, you need to draw before enhancement, after enhancement. Then, based on the given conditions, you set up equations. Okay? Yeah. So after that, last step, solving algebraic equations. Still, you need pretty good algebra skills to do it. Okay? Yeah. So if you do all these parts correctly, then you can get right answer. So think about, So for questions in this part, a little challenging. All right, So we finish example 12, then example 13. Similar type of questions, but slightly different. It is not hard, but I want to give you this example to show you there is a possibility to work in this way. That's it. Okay. All right. So let's look at a question. In a computing task, a subtask that uses 1/5 of the execution time can be enhanced with Speedup 3. But that's the first subtask. Okay. Another subtask, second subtask, uses 1/3 of the execution time that can be enhanced with Speedup 5. So that's the difference. part that could be enhanced, there are two parts, not one part. Our formula we used is just for one part, but here we have two parts. They both can be enhanced, but with different local speedups. 1, 3, 1, 5. Now the question I want to ask you, how much is the overall speedup? So you cannot use the original formula. You need to derive a new formula, but based on our analysis of the original formula. So that's what we should do in this example. Yeah. But it's pretty straightforward. Yeah. The bottom line is you have to understand how do we divide the original speedup formula. All right, so we start with diagram. Oh, sorry. Yeah. All right, so we start with diagram. All right, so let me draw a diagram. Okay, all the execution time. Now I need to divide it into 3 parts. F1, yeah, so let me just, the first part, F1 equals 1/5. S1, local speedup, equals 3. F2 equals 1/3. S2 equals 5. The remaining part, 1 minus 1/5 minus 1/3. No change. Okay, so no change. All right, so now speed up overall. Speed up overall. One over. Okay, yeah. Think about it. T old cancel out. Top, bottom cancel out. So 1 in the numerator. Okay, all right. F1 over S1. How about that? F2 over S2. How about that? 1 minus F1 minus F2. How about that? Okay, yeah. That's simple. That's straightforward. Yeah. Because the bottom part, that's how we represent T new. Although we cancel out T old, if we put T old in, that's the T new representation. Okay. Then it's very easy. We just plug in the numbers given. F1, 1/5 over 3, so 1/15, right? 3 times 5 plus F2, 1/3, yeah, another 1/15, right? Yeah, plus 1 minus 1/5 minus 1/3. Yeah. So then you do calculation, you can get the answer. Okay? Yeah. Calculation part is pretty easy. The harder part, based on my experience, I gave this question to some students before. The biggest part, they don't know how to do this part, how to handle those 2 enhanced fraction part, like this way. Okay, so after you see this example, so later, so when you work on the similar questions, you can use the same way. Okay, so you can easily generalize our original formula to this version. Think about that. Okay, all right, so let me complete the second example and also the whole video for this part. Yeah. All right. Yeah.